and where you are chatting from or where you're connected from, and possibly what you do and your affiliation. This is the time to network. People can know you, know what you do, and know where you're connected from. If you have any social media handle or any how you could be contacted, you can also share it on the chat box. Without much ado, I would like to before I introduce the speaker for today, I'd like to bring up the director of the lab in the person of Professor Collins Odano to give us a short speech before we start. He's going to start with a short speech, and he's still going to end the talk with a closing remark. So I would give it up to Professor Collins Odano for just a short speech telling us how the lab goes and what is in the lab.
All right, thank you so much, Dr. Blessing. Thank you for doing a wonderful job for us. I welcome every one of us once again. Today is another day. Today is the fourth in the series. And today we'll be looking at advanced topics in AI and data integration. I'm sure the person here, some of you she may be new, but to me, very familiar with her and her works. So I'm expecting a lot today. I'm so excited to be here tonight. So once again, HiPIC Lab, that's a high performance and intelligence computing lab based at the Department of Computer Science, University of Nigeria, is a multidisciplinary research lab, and our work centers on health informatics, agriculture, and languages, natural language processing, in addition to others that we collaborate with. So far, we have done some work. We've done a number of research projects, which you can find on our website, hipiclab.org. You will see more about us there. And the previous webinar that has been done in this series, also on that platform, you can get more information. And by the time we'll be rounding off this evening, we'll be summarizing all that has been said so far, and will give us details on our next programs. So I want to welcome you once again, and I say relax, because today is going to be great and impactful. Thank you. Over to you, Dr. Bokri.
All right, thank you very much, Professor. And like he said, it has been a very interesting and knowledge-packed event over the 3 weeks that we started this program till now. And today is going to be a very interesting one, because we have one of our best in the person of Professor Mpho Primus, who is going to be talking about some high data integration strategies in responsible AI and ethics. So it is my honor to introduce the speaker for today. Our speaker for today is Professor Mpho Primus. Professor Mpho Primus is an NRF-rated researcher specializing in computational linguistics and serves as the co-director of the Institute for Intelligent Systems, University of Johannesburg, South Africa. She's the founder of Primus Technology Hub, a boutique consulting and advisory firm specializing in data strategy. Professor Mpho is dedicated to advancing technology through the art, currently focusing on creating multimodal data sets for African languages using traditional stories, songs, and folklores. This work not only enhances technological development for local languages, but also preserves our heritage. She is also a trustee on the Edemia Black Women's Ownership Trust and a member of the advisory board for the Pan-African Information Communication Technology Association, Ladies and gentlemen, I present to you Professor Mpho Primus. Professor Mpho Primus, over to you.
Thank you so much, Dr. Blessing and Prof. Collins for inviting me today, and everyone for availing themselves. It's a Friday evening in South Africa right now, so thank you so much for everyone for kind of availing themselves. And thank you so much, Prof. Blessing, for the kind introduction. You and me come way back. We've known each other for quite a long time, and it's always a pleasure to work with you on projects. Nonetheless, in the interest of time, I think we're just going to delve into today's talk, and I will switch off my video while I do this. So, on today's topic, we'll be exploring the need for explainable AI systems and models, in further enhancing trust, allowing the stakeholders to which the systems are developed for to actually adopt them, right? As we all know, that AI-powered systems and models have transformed how we actually operate in industries and in our daily lives, right? And they've kind of revolutionized the way, across all sectors, be it the arts, be it healthcare, be it finance, how we operate, and also how we innovate, right? We co-create with the systems now. For instance, in healthcare, we see the systems or models being used particularly for, in early disease detections through advanced image recognition. And I know that Prof. Blessing is quite active in the space of AI in healthcare as well as education. We also see how the systems have penetrated finance, right? Enhancing fraud detection, algorithmic trading, personalized financial services, fintech, and making transactions more faster and kind of leveraging also on the risks. We are seeing also in Africa the push towards what we call smart cities, right? And this actually leverage AI in how they operate. For instance, optimizing traffic management, improving energy efficiency, particularly in the context of South Africa, this would be nice, and boosting public safety through real-time data analytics, right? And, not leaving behind the retail sector. Manufacturing is one of those industries that jumped on the AI revolution in the early days by using, AI-powered automation, predictive maintenance, right? Thereby allowing them to kind of increase efficiency. So it's by no claim that AI has very transformative power in automating tasks, but also unlocking new ways of doing business and reshaping how we run our lives, and as well as how these industries collaborate, innovate, and deliver value to their intended customers or clients. Now, while we talk about this transformative bright side of AI, its effectiveness actually depends on two things, right? Explainability as well as data integration. Now, these models require huge amounts of data from multiple sources to actually give you accurate insights that you can do something with, right? And therefore, it is quite important that we integrate this diverse data sets from all kind of data sources. It may be Internet of Things, sensor data, it may be the internet, for itself. We use the internet as quite a huge data source. But this structured and unstructured sensor data presents a very huge challenge in terms of quality, consistency, as well as scalability. Now, it is quite important that data integration is actually given the right attention so that we actually get quality information from the systems and allows us to make the most accurate as well as informed decisions. Adding on to it, equally important is explainability. So what does this mean? This means that what is the ability of the systems to be able to tell us how they get to conclusions, right? How do they explain to us how they go to a decision? If you ask your medical doctor how they diagnosed you with the disease, they will actually tell you how they got to it. One of the biggest problems that affects the adaptability of this AI-powered systems and solutions has been this black box effect. Not us being able to understand how they get to certain decisions. It is quite important that we can actually get to a point where the systems, and we're already there, by the way, right, as we will see today, can actually make specific decisions, particularly if you think about high-stakes industries such as healthcare and finance. Explainable artificial intelligence solutions and models and systems are quite important for building trust, ensuring accountability, and also making sure that they comply with the relevant regulatory requirements. Now, without this transparency, the solutions, those models, the systems risk becoming this black box technology, and this influences user confidence and slows the adoptions in these sectors. And one thing that we don't want to do is deploy technologies that people don't want to use, right? We can, talk about that in another session. Now, just zooming into first and foremost business of today, explainability and how do we actually interpret what we get from the systems. Now, explainable AI has been, increasingly important, particularly in the past 5 to 8 years. Because as we deploy the system, particularly in critical areas such as healthcare and criminal justice, we've always talked about the system biases. If you look at examples that came from the global north, particularly the US, in terms of bias when they were deployed in policing, this kind of showed us why it was important for us to understand how the systems get to where they get, as particularly how they give us the output that they give to us. Now, the complexity of these modern models, especially deep learning algorithms and the complex architecture, often results in the systems functioning as black boxes. What do I mean by this? They produce decisions and results or predictions without a clear understanding of how they arrive to actually these conclusions, as well as the sophistication, the sophisticated algorithms that they use, right? The self-learning algorithms. Now, this poses a major challenge with stakeholders, right? And this is from consumers to regulators, demand to know the rationale behind AI-driven decisions. In Africa, this is quite a huge gap, particularly because we are now climbing on the waves and we're trying to kind of catch on the waves in terms of legislation and regulation, right? But if you don't understand how the systems come to a conclusion, then how do we then regulate them? Now, the field of explainable AI aims to bridge this gap by providing us with transparency. So it allows humans to comprehend the inner workings of these black box systems. Now, this is very, very important, not only to build trust, but to ensure that there is compliance and accountability with ethical standards. Now, despite those potential benefits of AI, we talked about the proliferation of AI solutions and systems in healthcare and finance, and also the ability to explore where it may be dangerous that human beings explore. I always make this example about the submarine that went into the deep sea with the clients that were in it, and then it exploded, right? If we had sent out a robot to actually explore and actually do a virtual experience of the Titanic through the use of robotics, it would have been a much safer thing. So these systems have huge benefits, but we still find people very skeptical about the use of the systems, particularly in academia. If you ask theoretical linguists, for instance, about using AI tools to better their research or to allow them to use these tools to do certain functions of the work easy, the first thing that they come to is that one of the things that we provide to the discipline is the ability to explain why things happen the way they do. And the inability of us to understand why the systems get to this prediction makes them quite useless to us. So without clear explanations, users fear that these models may be biased or prone to making mistakes. And this can be actually quite difficult if you think about high-stakes sectors, right? Where we have decisions that can be life-altering or have life-altering consequences, and basically also sectors that are quite regulated. Now, in industries where decisions have very significant ethical, legal, and safety implications, explainable AI becomes quite a huge factor, right? For instance, in financial institutions, for fraud detection, credit scoring, investment, it is quite important for us to understand how the systems give a person a certain credit score, how they arrive to it. And we'll talk about certain models that exist already that one can use to actually track how they get to a decision. Also in healthcare, treatment recommendations, it would be nice to know how they got to actually recommend a certain treatment. So this is why explainable AI becomes quite important. Now, the lack of explainability in AI, particularly in these models, not only slows down the adoptions of those technologies that are powered by AI, but also gives resistance to stakeholders who may fear these unintended consequences that may arise. If they're prone to bias and they're prone to mistakes, people just don't want to touch them. Also, there's also the fear of legal repercussions. What happens when it gives the wrong decisions? Are we kind of now, safeguarded legally, from certain, repercussions that may come arise, right? So, in summary, what is explainable AI, right? Explainable AI is an ability of a system to make its decisions and be able to make those decisions understandable to human beings beyond just giving it output and giving you, from the input given. So that black box that I'm just showing there, this is what we want to get rid of. We need to know what happens inside that black box, right? Why is this important? Well, for instance, if a doctor if a doctor is very skeptical of using an AI tools for diagnosis, they will also not be more keen to use it. Now, we know that the systems do make our life easy, right? We are sitting all here today across the world having this talk because of these AI tools. We need people to understand that. We also need people to understand that they're not here to replace life, but they're here to complement how we actually go through our daily lives. Right. Now, another thing that I want us to also touch on, that we'll touch on again today, is what is the need for data integration? The need for data integration, hand in hand with explainable AI systems, is underscored by this increasing amount of data that is generated across various industries from various devices. I would say even when you sleep, you're generating data, right? When you're sleeping, you're telling Google how many hours of sleep you're getting on average, right? As you walk, you're generating data with those smartwatches. So every piece of our lives generates data in this day and age. As I drive my car, the GPS in my car can actually now calculate how many kilometers I make, how much my driving style, how much, petrol consumption I use. It can do facial recognition to see who's driving my car at this point in time and tell me all I need to know about my driving style. So all this data that has been generated, right, from different sources, how do we then put it together to gain meaningful insights? How do we then, for instance, if you think about in organization, in universities, at work, and banks, right? Now we have moved towards we are now talking about the transformative power of data, leveraging data insights. We see this proliferation of data and data strategy. But if we don't understand how we can use all this data that we generate to gain competitive advantage, if you think about the public sector, to actually deliver on the mandate and deliver public services to the citizens, then it hinders what we need to put into place. Now, integrating data enables, whether it's organization, companies, the public sector, to break down silos and foster collaboration across departments. Imagine living in a society where with just my ID number, right, the government can track me from birth until death and deliver services that are relevant to my needs at each and every point in my life. A government that can actually track where everyone is and what services are used and needed. A government that can predict if an outbreak is coming and preempt and provide services prior to the outbreak that is actually coming. So this is why data integration actually is quite important. from all the data sources that we have, from all the data that is generated, how do we put it together in a way that makes meaningful, insights, and that we can draw meaningful insights from. Now, back to explainable AI. What techniques can we use to make sure that we can actually track how the systems get to the point that they take? Now, in terms of neural network and intrinsic methods, different scholars have different viewpoints on this. Some scholars will say, no, but neural networks are also quite intrinsic. Some will say, no. Actually, if you cut and chop it in a certain way, they become quite extrinsic. So for the sake of this presentation and this conversation today, we're going to support them. So one of the first methods one can look into is actually post hoc techniques, right? And this is basically explaining predictions that are already trained on the model itself. And one of the examples is what we call the local interval model agnostic explanation, right? So in simple terms, for instance, if an AI predicts that a patient has a high risk of diabetes or a high risk of heart disease, Lime, L-I-M-E, could actually create quite a simple model based on the patient-specific data. So it would, for instance, if you're at risk or there's a risk of heart disease, one would have to look at your cholesterol levels and age. So Lime could actually just create a simple model based on the specific patient's data to explain why that prediction was made to be the way it was. So it does this prediction, it explains the diagnosis post the prediction. Intrinsic methods, right? These ones are actually intrinsic by design. So those of you with a computer science background can, one of the simplest examples is decision trees, right? And those without a background in computer science, think about a tree with branches and you climb it. So you can see if I want that apple, this is how I need to climb the tree, which branch I need to climb to the tree, which leaves I need to remove from the tree to get to that apple or peach that I want to get to. Now, computer science speak. Decision trees allows us to have models that mimic human decision making, right? Following a tree-like structure. So they're quite very easy to interpret and visualize. We can see it, we can follow a path and see how the system got to where it is. And this is why here we actually say the intrinsic. So example, back to AI in health. A decision tree predicting whether a patient has diabetes may, for instance, split the data by age, and then split the data by glucose levels, and then split the data by cholesterol levels, and so on and so forth, depending on I'm not a health care expert, depending on the factors that affect diabetes, right? And each part in the tree can be now examined and visualized, remember it's a tree, to understand exactly why a certain decision was made. So if a decision tree predicts, for instance, in finance, that a customer, based on a certain age and income, will buy a certain product, right? This is basically an example of AI in marketing. One can easily trace the path through the trees to actually see what features at each level of each branch and actually influence how it got to a certain decision. I think that is clear, right? Another example that one can think about in retail, and we see the penetration of AI powered solutions and tools in retail, right? Decision trees can actually segment customers based on their purchasing behaviors. So for instance, those who are rich enough and frequently buy expensive sports car equipment or sports equipment and have high disposable incomes are more likely to respond positively to targeted marketing campaigns. So when we want to decide how do we then market a certain product, we look at their buying patterns. And a decision tree can actually show us and segment these customers based on their purchasing behavior. Now, neural networks use what we call attention mechanism, right? One of the things that to put in mind is that a lot of the tools and solutions that we have today do not just follow just one model or one method. It's usually it's a hybrid of certain models depending on what is actually needed at a certain point. Now, neural networks due to the complex, architecture and this multiple layers that they have, they make understanding decision-making process difficult. So these are actually the culprits of black box effect. If you compare them to, for instance, decision trees, right? Decision trees are quite simple and straightforward. They allow us to just go straight into it and get immediate interpretation. However, if you look at something like, CNNs, right? Convolutional neural networks, and you think about if you were to use this in image recognition, in terms of, image, classifying an image of a cat with high accuracy. You can do that. You can actually get a high, accuracy of always managing to actually get an image of a cat or a dog. But understanding how it got to that high accuracy is very, very important. It's very, very difficult if you think about neural networks such as CNNs, right? Because it is difficult for the systems to tell us which features were used. Color, shape. How do we classify a cat? Let me know how you got to a point where you're saying this is a picture of a cat. If you now use what we now have, generative AI, and you just say, I need an image of a braai, gives you an image of a braai, and every time you ask it to give you images, they get them right. But the question is, if you ask it how it got, and you can try this with any of the generative AI tools that we have now. If you try to ask it to explain to you, how did you know that this image is surely an image of a braai happening, is surely an image of a cat? How did you get to this point? What steps did you take internally in your engine to get to this point? It becomes difficult for us to then now understand. And this is why we call them the culprits of the black box effect. Now, in summary, the distinctions lies in the model's nature. The model that you use when you want to, have systems that can be understandable to human, how they actually get to a certain points, it all starts with the developer. What are you using, right? You need to be quite intentional about it from the start. Am I going to use intrinsic methods? Am I going to use post-hoc intrinsic methods? Am I going to use neural networks? Am I going to use a hybrid of both? It all depends on the actual developer. And it also has its pros and cons. You may find sometimes that, you can have systems where you say, look, I only need to explain certain parts of how I got to a conclusion. For instance, think about in a transformer-based model for NLP, natural language processing, right? You may say, for instance, attention mechanism is one of those techniques that you can use where you just want to highlight the most important parts of a sentence, right? To contribute to actually classification and decisions. So you only pay attention to certain components. That's why we call them like attention mechanisms, and classify this as these are the most important ones that I actually have to look to contribute to my classification decision. Now, this gives users insights into which features or inputs were most important in the model's prediction. And this is also useful in things like machine translation for those in NLP, those also in speech processing. These are the things that one can use in terms of neural networks that can be accountable to a certain point to humans as to how they get to a certain level of point. So even in neural networks, we can achieve a certain level of explainability using a method such as attention mechanism. But this is quite important to know that this just puts a blast on certain features and classifies them as the ones that are most important to get to a certain decision. Now, data integration, right? And one of the tools that aims to achieve explainable AI is the IBM's 360. So you guys can use it. There's a demo for it. You can go into that, and there's tutorials on it. The AI Explainability 360 by IBM. There's also other tools that one can use for explainable AI. I'm sure you can actually look into that on your own and play around with Google. Now, data integration. Now, in today's data-driven world, all organizations are facing the same significant problem when they try to actually acquire tools, right? So we have come to a point where we have all these solutions, AI-driven tools and solutions that are just being, marketed to us. Buy this tool, buy that one. Even big organizations, Microsoft will come and say, buy this tool from us, and then we have a partner with this one, and then that one will sell you another tool. At the end of the day, you have all these nice tools, and you're only using 10% of the functionalities. Now, this is a better return on investment, first of all, and second of all, it doesn't give you the value that AI tools aim or claim to be giving out this in terms of return on investment, right? So what does this mean? The publication of AI tools is there, is here, it's everywhere in the world, in the global north, in the global south. These tools are here. But now we have a problem with how we manage our data, right? Getting this data from everywhere. Customer transactions, customer contracts, unstructured data from social media interactions, real-time data, generated by IoT devices. What do we do with all this data, right? A lot of the time, this data actually leads to a lot of fragmentations. So they sit in different places and no one, very few people know where all the data sits. So if one person is in another department and they get hit by a bus, a lot of the times organization can't even access that data. Now, this actually gives us a problem with when we say that AI tools helps us get faster decisions. But if we have insufficient information that is caused by fragmented data and siloed data, then we are not getting this claim that we're making that we are actually going to get comprehensive insights. Because if you don't have comprehensive data sets, you cannot claim to have comprehensive insights. Moreover, the diversity of this data, remember you have data from social media, from IoT sensors, they all come in different formats and standards. Now, this is another layer of complexity to data management. For instance, while you have structured data, so customer records, customer transactions that are structured, it's easy for you to query and analyze that kind of data. But data from social media and emails require much more, right? You need some form of capabilities to actually extract valuable information from it. For instance, from social media, you would need natural language techniques to manipulate and get meaningful insights from the data. And you're asking, but why would organizations be interested in social media data? Because we have things like digital marketing. Before I put my product in the market, I need to know if people are ready for it, right? I need to know what people are saying about my brand and my product before it comes out. I need to find a way to influence people to be ready for this product to come out. And this is, the rise of social media, the rise of this AI tools and AI-powered solutions has also even given us rise to new professions, right? We now have influencers. Brands have just realized we can ask someone with a lot of followers to actually talk good about our brand, then more people will talk good about our brand, and then it gets more and more influential, right? Now, what are then the benefits? I've just been talking about the problems that exist in data. Now, the benefits of data integration is that it allows us to have one singular view of the data in our organization. So it actually allows us to have this very, very comprehensive and richer insights, right? When we have integrated data and data sets that are standardized, it makes it also easier to analyze them. And when we can analyze them, it actually helps us to get more meaningful insights. When we have more meaningful insights, it assists us to make better decisions for organizations. So basically, this is the benefit of this data integration. For instance, I'll go back to healthcare, right? Data integration in healthcare allows us to have this holistic patient care. If you combine medical records from, the medical records data from their wearables, lab results when they take lab, and then you have this one view of the patient, right? It allows us to have personalized treatment plans. It also enhances portability from one service provider or one healthcare provider to another. And it also allows you to actually have more accurate recommendations and treatment and predictions on the data. Now, quality, scalability is really one of those challenges that we have, right? Quality, inconsistent, incomplete data sets, right? We always say when it comes to AI, it's nonsense in, nonsense out. So if you give it inconsistent and incomplete data, you get inaccurate predictions. That is a key point of it. Different data formats, they need to be put into the same standardized data format. They need to be harmonized so we can effectively actually, do analysis on them, right? AI models need to really process large amounts of data in real time. So this requires us to have very efficient data pipelines. So one needs to think about data infrastructure. I mean, whether in the global south we are ready, for the conversation of data infrastructure is also another so for another day. Now, what do we know? A lot of techniques exist in this day and age. One of the well-known ones is the ETL technique. So you extract, you transform, and then you load. This is really one of the most that has been used by a lot of organizations. So what do we mean by extract? You gather raw data from different sources, and then you transform it by cleaning and normalizing it. Remember, different sources give you different types of data in different kinds of formats. So you need to transform it to one singular format so it's quite consistent. And then you load it. It means that you store the data in the right repository, right? Of course, when we talk about integration, if you look at a lot of this data management frameworks, you talk about security and accessibility and so on and so forth, but this is not for today's talk, right? There's also other ones like data federation. There's a lot of models that actually exist. But the message that I really want to actually drive today is that it is quite crucial that we have integrated data, right? In the right format, in the right repository, with very, very strict access and privacy. Now, you can achieve that with other techniques, right? You can think of, oh, can I use blockchain for this or this for that? But that is kind of specific to your problem at a certain point. And one would actually select the right technique based on the set of specific needs and data environments. So whether you want to do ETL to do your data integration, it depends on the needs and your environment. And if you're a startup that works in data and data management, you would know that it depends on exactly what your client would want. But the fact is that you cannot get meaningful insights without good data. And the first thing to achieve good data is actually integrate and manage your data correctly and have a data strategy. So that is the message that I'm trying to drive today. Now, what happens when you have this inconsistent data, right? So if you think about schema mapping, so think about a healthcare organization. We have, that a lot of sort of stores that patient data in a database, right? My SQL and then, treatment history in another, no SQL database, right? Now, your schema will have different tables for patient treatment visits, while the other one, where you store the treatment history, might not represent or might just represent patients as just a document with just document and inside as just embedded treatment history. So schema mappings allows you to actually say, this is Mpho's information, but also there is where Mpho's patient records are and actually map these things together. We also have data cleaning, right? Here you would actually have to kind of identify and correct inaccurate records from your data set. You will also have to think about duplications, how you deal with duplications. And we've seen this this problem of duplications when we had this airline that had a major issue with duplications of customer records, and this affected their loyalty program. Imagine if I have duplicate records for one of my my frequent flyer miles. Right, they duplicate records. Every time I fly, sometimes the points get allocated to this number, and then other times it gets allocated to the other number. So my miles never are integrated fully, and that means I can never get the right benefits. I can never get bumped into business class because of my miles are distributed across 2 different profiles. And those 2 different profiles actually belong to me. So this is what we call, this is what data cleaning would do. Normalization usually deals with when you get these different data formats, and you need to put them in a way that is this quite simple one representation. So this is what we call normalizing a data, standardizing the data, basically. One might think, for instance, and this is a very something that we never ever think about. Think about dates. Dates come with multiple formats. You can start with the month, the day, the year, the month, the day, the month, the year. So in certain instances, you have a transaction written in one format. In certain instances, you have a transaction written in another date format. But you need to normalize them before you actually integrate them for analysis. Right. So in summary, one of the things that affect us getting the right return on investment from these AI tools, one of the things hampering us getting the right value or the maximum value from the systems is these 2 things. A, fragmented data and not having data strategy, right? And not being able to manage the data that we have. And number 2 is what we call technology adoption and acceptance. But what affects technology adoption and acceptance is because people believe that the systems have gone haywire. And why do people believe that? Is because of this black box effects. You give it output, it does whatever it does in there with this algorithms. It gives you an output without explaining how you got to it. So basically, people view the systems as being, trust me, I'm a doctor. So doctor, how do you say that I have diabetes? Trust me, I'm a doctor. Now, if a doctor says that to you, you are not going to trust them. And you are not going to go back to use those doctors. So technology adoption is actually affected because of the lack of explainability, of which the field of explainable AI has been looking into this for the past 8 years or a decade or so. Now, in summary, as we stand at the forefront of this revolution, and it is a revolution, and the train has left the station, right? And we see that these tools are now in our daily lives, right? From the chats that we use, from transport, it is there. We cannot run away from it. However, in order for these tools to be truly effective, they really need to cultivate a foundation of trust. Not only for user adoption, but also to get the maximum of value from it. So explainable AI plays a very, very important role in the trust building process. If we can demystify the decision-making processes of AI systems, we then allow users to understand and validate the outcomes generated by these models. If doctors have AI solutions that they can work with in their diagnostics, and they can trust that, and they understand how the solutions that they have on their hand to help them in their jobs actually get to certain conclusions, it makes it easier for them to actually use the systems. It fosters trust, and you cannot foster trust if we don't invest our research and time in explainable AI. Now, furthermore, as we then integrate data from multiple sources, right, in enhancing our systems, the systems are very data hungry. So you have to keep them data. So we're getting data from everywhere. For one system, we'll get data from everywhere, right? In doing that, it means that the need and the importance of data management and data integration cannot be overlooked. Because effective data management integration allows us to have more meaningful, comprehensive insights. And furthermore, they allow us to have more robust AI models. If you can have a model that can get any data and learn from any data, whether it's music, video, audio, pictures, and can actually then integrate and transform this data into meaningful insights, you would have unlocked a much more powerful systems than you would have if it could not do that. Now, without addressing these challenges that we have with fragmented data sitting wherever it's sitting, where no one knows sometimes where it is, it makes it difficult for us to get meaningful data sets. Now, in this context, I cannot stress enough the need for a well-defined data strategy, right? A comprehensive data strategy allows us to manage and integrate and utilize data, not only effectively, but ethically, right? You don't want people with the wrong accesses to access your data. You don't want people to access your ID number if it's none of their business. For instance, I work in academia. I can only access courses and marks, right? Make mark changes on the courses that I teach at a certain point in time. Once I finish teaching that course, I lose my access. This is why this is important. So I don't get into another professor's course and change it. Now, in summary and in conclusion, the intersection of AI, trust, and explainability and integration represents a very important landscape, right? And allows us to move the needle from where we are and where we want to go in this AI revolution, and how we usher different industrial revolutions that we've had, from the third revolution that was technologically driven to now where we are with the fourth and the fifth industrial revolution. And as we continue to play and innovate and deploy the systems into our daily lives, it is important that we prioritize trustworthy in our systems, right? And explainable AI plays an important part of it. And it's also important that we enhance how these decisions are made by the systems. And this is by giving them quality data. And you cannot give quality data if you don't have a strategy around it, if you cannot integrate different forms of it, and if you cannot manage your data correctly. So by doing so, thank you, Prof. Collins. Thank you, Prof. Blessing, for the opportunity. I do believe that we have 7 minutes for some discussions and questions before closing. Thank you.
All right. Thank you very much. What a wonderful talk today. Thank you very much for Professor Mpho Primus. I told you guys that it was going to be a very interesting one and a memorable one. What a way to conclude our webinar series today. Just a recap of what Professor Mpho was telling us here. She was talking about advanced topics in AI and data integration. She made mention of interpretability and explainability. When you're building, she also mentioned when you're building your machine learning models or AI models, it is important for stakeholders to understand what you are doing. When you make a prediction, why did that prediction go that way? What are the things influencing your prediction? You need to make, someone that is not tech savvy or technologically sound to be able to understand what you are talking about. And she made mention about, having to work in a medical system or medical environment where you are using building models for medical people. They are not IT people, but you are building for them. So they need to understand what the model does and what are the factors or variables or features influencing the model or influencing how the model is behaving or influencing why the model took the decision is taken. That is actually the whole background about model interpretability and explainability in model building. And she also mentioned, talked about data integration, how you normalize your data, how you put your data in a way that it can actually make much sense. So without much ado, I would like to have us read some questions. If you are putting your questions in the chat box for Professor Mpho. Do we have questions? Let me see. Okay. Please, if you have questions, you can put it in the chat box. While we are waiting for your questions within the short time, can we, Professor Paul, you can start sharing. Can we all put our, if you have good background, you can put up your camera. We want to take a screenshot of everybody participating today so that we can put it, can put it in our report. So you stop sharing, Prof. Thank you very much, everyone, for participating. So let's go back to the questions. So, Professor Paul, this question is for you. This question is coming from Mustafa. It says, why is explainability important in the development and deployment of AI systems?
Created automatically bots. We saw also an instance where certain, Facebook also had a problem where the self-learning algorithms went a bit haywire and behaved in a way that could not be explained. So these are social media sites. You can say, well, but it's not really high intense. But if you think about if systems can now create their own bots without human intervention and no one could understand why they created bots, and how the sites make money is through the number of people that are subscribing to it. Now, if you create 20 million bots and we cannot explain or understand how we created the bots, and now we are inflating, right, the valuation of our company based on false results that we also cannot explain, it becomes a big of a problem. Now, this is what makes people say we don't trust the systems, because honestly, for a long time, we could not explain how they learned. And as the big data revolution started in the early 2000s, and with the sophisticated algorithms that are coming up and models from machine learning to now deep learning, and these complex architectures, it became quite increasingly difficult for us to explain. And this question then started coming around, 8 years ago, to say, how do we get systems that can tell us how to get to the conclusion so that they can enhance trust, and so that when they misbehave, we can explain why they misbehave. Wouldn't it be nice if OpenAI can come and tell us why sometimes ChatGPT hallucinates, right? What causes it to give us false answers sometimes when we ask for information, so that we can stop it from hallucinating. Imagine a doctor using an AI-powered solution that hallucinates 30% of the time. So it can give a misdiagnosis 30% of the time, and we cannot explain why. Would a doctor then be comfortable using the solution in the surgery? The question is no, because in the medical field is very, very highly regulated. You cannot misdiagnose 30% of your patients, or you cannot make 30% misdiagnosis. You should not be a practicing doctor. So not understanding how the systems work really, really have real life implications for us.
All right, thank you very much, Professor, for your answer. We still have some more questions here coming in. We'll see how much we can attend to them. We can use the next 10 to 15 minutes to address some of these questions.
I can see them, I think.
Yeah, I'll be reading them for you. Don't worry.
Okay.
So that we'll go together with it. So there's a question from Mankoba Swani. He says, thank you so much, Prof. What is the difference between a data warehouse and data lake? Okay.
Simply put, a data warehouse basically, and this is what a lot of companies use. If you have a lot of structured data, you use a data warehouse. It allows you to have faster queries and analysis. And if you have clean data, you go for data warehouse, right? Data lake it can take both structured and semi-structured. You never want to have unstructured data, but of course it can take unstructured data, and it allows you to have all these different formats. And you can store very large amounts of it.
All right, thank you very much. That's an interesting one. Onyinyechi Osai is asking, in what way can poor data integration lead to biases or errors in AI outcomes? And how can we mitigate these risks?
Okay, so a simple example came out, right? I think it was during COVID. There's also a book called Unconscious Bias, right? And One of the things that we do as AI practitioners, and I think I see my Nova as a tech entrepreneur, we sit in a room, we come up with a solution, and then we start, okay, we need to train our data, and then we go in and provide data. Not forgetting that, remember, the quest of AI is not new, right? It started even as early as the 1700s. But what has pushed us now, and a lot of the technologies that come out is through this race, is the eye. Initially, we were trying to model human intelligence in its entirety into a system. And then we realized, okay, everyone is now sitting in their silos. NLP, computer vision, how do people see? They see in this way. This is what computer vision is based on. How do people talk? How do people process languages? How people learn languages? Then you have NLP sitting in its own corner. You have people, everyone is sitting in their own silo trying to model, for instance, neural networks, right? This is the pursuit of how brain morphology works and how we can do that into systems. Now, in getting human intelligence into systems, one thing about human beings is that they're biased. And the problem with our biases is that some of these biases have been structural. If you look at the example of South Africa, you don't want a system that uses historical data in the financial sector. Because if they were to say, okay, how do we then assign interest rates to black and white people? Okay, we use historical data. But if you look at who was banked in South Africa in the 60s, who was banked in the 70s, who was banked in the 80s, who was banked in the 90s, and you feed this data to say, this is financial data, this is Perez, then we can now train the models. The models are going to have more data set for a certain race, and the other race will be marginalized. And this then has real life implications as to how much interest rates are given to people, and financial implications, and access to credit. So this is why then data management and integration can actually lead to errors and biases that have real life, particularly because the softwares and the technologies are part of our society. I hope that answers it.
Yes. So the next question here says, this person is Geoffrey Rombe. Geoffrey Rombe is saying, what measures should organizations implement to ensure that AI systems are designed and deployed in a manner that is fair, transparent, and respect users' privacy? So what measures should organizations implement to ensure this?
Unfortunately, organization can't implement it. The people who can implement it are the people deploying and developing the tech, which is big tech. The Googles of the world, the Metas. This is their job. To actually ensure that before they give this to organization. If you think about universities, we all are now on Zoom or the Microsoft Suite, but we got this. We cannot ensure that it's transparent because we didn't create it. And this is a problem with tech colonization. This technology has been developed in the global north and been deployed to us. We cannot, we have no say in how they work. So big tech needs to be held accountable. But if you follow what big tech, every time they get hauled to court, they run away from accountability. So the end users really cannot, unless if you stop buying them, but that's a story for another day. If you're saying then Africa should stop boycotting and start using our own products, for instance, then we can now have a shot at saying this is how we want them to be designed and deployed. Yeah.
Exactly. So thank you very much. Just in addition to that, just when we talked about ethical frameworks, right? Here you see organizations can now, follow some ethical frameworks to implement some of these AI technologies. It's also very important. Even like now, we are using Zoom, like Professor just said, and we are chatting, sending messages, text on the chat. We don't know what happens to these texts. Don't know even if someone somewhere is monitoring what we are doing. You're recording the section, and it goes to a server somewhere. Somebody uses possibly to fine tune and train their own model without our consent. It can happen, So those ethical, we have little or nothing to actually do at this case, because some of you or some of us use Zoom in our various institutions, and we don't know how it was implemented. We don't know who championed the whole process and all that. That being said, let's take 2 more questions, then we'll take it off. We'll end it from there. The next question I'm going to take right now is, what is the solution? That's coming from Teboho Mahalati. Sorry if I didn't pronounce your name very well. So Teboho says, what is the solution for the vast amount of missing data in health sector, particularly here in South Africa?
I mean, look, South Africa to its own benefit has started the digital transformation journey and digital transformation. You know, they are really, particularly for instance in Gauteng, we are really walking the talk. The missing data in the health sector is caused by the fact that honestly it was never digitized. If you have a copy of a book and you lose a copy of a book and you don't have other copies of it, it's a problem. And this is the problem with hard copy, you know, data on hard copy that is not safely guarded, that is not put in the right way. Because, for instance, even if you put it in a safe and then you get a flood, it's out. And this is why this digital transformation is an important first step to safeguarding very important information, such as health, people's health records, people's you know, financial records. Yeah, but the fact is, without digital transforming the sectors, there's nothing we can do.
Mm-hmm.
Yeah.
All right, thank you very much, Professor Mpho. There's a question from Isaiah Uwabo Obaseki. He says, what are some of the lucrative courses or lucrative trendy areas of AI that you can recommend enthusiasts like me to go into for study? Okay, maybe I could just answer this. You know, the reason why we are doing this webinar series is part of this thing this kind of question you asked. We have 4 areas that we've already identified, and we did had some talk about them. The webinar was actually, the general topic is advancing AI, ethical AI, you know. However, we had different sections that you can pick as an area to, you know, start reading or start developing yourself. One of them is the first section that we did, where we had we talked about fundamentals of machine learning and data processing. And that was treated by a very renowned person, Dr. Chinedu Nwoye. So you can actually decide to build yourself or develop yourself in the fundamentals of machine learning and data processing, data pre-processing, to learn more about it, learn how you can use machine learning to build models and all that. You can also go into that data governance. If you feel, okay, I don't want to do too much of coding, I don't like programming so much, you can go into data governance and understand how the governance of data is actually done. That way, you can build a career in that. You can be the one, you know, championing the policy that guides the data that people use. Then if you feel you want to go further, you can also think about going into responsible AI and ethical considerations. You can go into building models that are responsible. And we talked about, I was the one that talked about it last week, you know, talking about models that, you know, should be fair for all. You know, if you want to go into that, you want to go into that kind of policy, you know, making sure that people are building models that can serve for the good of the people, then you can decide to build your career there. And to crown it all, today we talk about advanced topics in AI and data integration. You can decide to go into that area, like the issue of explainability, issue of transparency. You can begin to, you know, study in that area, or even data integration strategies. You can begin to build your career in that and write the exam. So these are different areas right now you can build your career. If you don't want to code, you don't do coding, you have options that you can actually go into without being a programmer and all that. Thank you. So let me see. Do we have one last question? Okay. So our director here says announcement. So this is just for everyone. We are going to send the link to all the presentations to your emails in the coming days. So I think we have exhausted all the questions. So I will have to, first of all, thank all the presenters. Starting from the first day, we had Dr. Chinedu Nwoye from France. We had Jeremiah from South Africa, who's also a tech startup guy, and myself from Canada. Then Professor Mpho from South Africa again. We are so blessed that we had all the talented and experienced people to give us a talk in these areas. Before we round it up today, I will give it up to our director, to Professor Collins, to actually give a vote of thanks. And Professor, please remember to mention or talk about the conference that is coming very soon that the lab is going to organize in conjunction with the computer science department, so that people can actually watch out for it.
All right, thank you so much, Dr. Blessing. Thank you so much, Professor Mpho. It's been very exciting. I'm glad that we did not miss you. One of the things I'm happy about is that people would have wondered if we are biased in not having a female as one of the speakers. So I'm glad that we have cleared this bias so that we don't speak about bias and then we commit the same error. So I'm glad that we had a female who rounded off the entire series tonight, and it has been very rewarding. I've shared the screen where we have a summary of all the speakers who spoke in this series. Like Dr. Bokri rightly said, Dr. Nwoye opened the series by giving a very detailed fundamental introduction to machine learning. It was so exciting. He talked about data, methods, algorithms, models, and tools for machine learning development. That video is already available on our YouTube channel, also on our website. Jeremiah talked about data governance, tools for data governance, the importance of data governance, reasons for data collection, and why we must get consent from the people who we are collecting data from. And we need to tell them the purpose of such data. And Dr. Bokri here talked about responsible and ethical AI. He stressed so much on bias. He talked about different types of biases in AI systems and how we can prevent such biases during our design of AI systems. And today you are witnesses that our own Prof. Mpho explained the need to open up that black box. You know, this is not the black box in Mecca, but the black box of AI. This black box that has encapsulated AI products that we do not know what's going on inside. So AI systems should be able to tell us how they arrived at their decisions, their conclusions, such that it will give confidence to users, especially in health informatics or in healthcare. AI systems should be able to explain to us how they reach their decision. And she talked much about data integration and a number of tools. So we are happy to say that we've come to the end of this series, and it was very rewarding, very educating, and very interesting. And it has also widened our knowledge and our desire to know more. Like I put up in the advert session on the chat, very soon you'll be hearing from us. We'll tell you what will happen next moving forward. Because we're going to be having, this is not the end of it, we're going to be having more webinars. And of course, there's room for collaboration. You have put up our email address. You can email us. We have your email. You see what we are doing, and we also want to know what you are doing and ways we can work together, whether you are a tech enthusiast, you are a startup person, or an academic, a researcher. There's room for us to work together. So I want to thank all our speakers, especially our Professor Mpho, who at the very short notice accepted this invitation. I want to say thank you so much, Ma. And I hope that when we call on you again, you answer us again. Thank you, Dr. Bokri. You have done a nice job in putting all this together. Thank you, Jeremiah. Thank you, Dr. Nwoye. And thank you very much for being here. I want to thank my friend, Makoba Zwani. He has been so consistent throughout the series. We have been working together using the HiPIC data set. We've been doing some work together, and I hope we're going to work more. So thank you so much, everybody, and have a great weekend.